is Sean at the Hands-On Science Center. I'm here with our Director of Education, Olga.
Hello.
And thank you for joining us for our very next take-home science kit. This is Cool Blue Light. I'm not sure exactly what that means, but we are about to find out. So, first step, I guess we dig into the bag and see what we got, right?
Yeah, let's see what we have.
All right, so our very important instruction book right there. We will be looking at that in a second.
A lot of blue I see on it, so.
Little teeny tiny cup of water. A pencil. And this container right here says the Cool Blue Light Experiment Kit. So we are going to be digging into that in just a little while. First, we're going to have Olga teach us a little bit about a really cool concept. So this says cool blue light, but I know there's a big giant word that we're going to learn today. So what is that word?
We are going to learn about chemiluminescence.
Chemoluminescence, that is a big word. So, first thing we want you guys to do, everybody's got their little booklet and a pencil. If you turn right to the very first page here, we got a quick little quiz that we're going to ask you to take. Don't worry, it's just a fun little quick thing. This actually helps us when determining how well our education programs are working. So, do we want to teach people if they already know it?
No, what's the fun in that?
Yeah, exactly. I love learning, but we want to make sure that you guys are actually learning. So we make these kits better and better each time. And it also helps us when we're applying for grants and things like that. So we're going to have you, on the front here, we do have to read one thing, very, very important. It says, warning, the materials in this kit are safe when used as directed. However, it contains chemicals that may be harmful if misused. This kit is recommended for ages 9 and up with adult supervision. So make sure you got a parent or another responsible adult with you when you're doing this. And stay real close to the computer or tablet or phone or whatever you're watching us on right now, because you're going to want to hit pause a few times as we go along. Now, speaking of hitting pause, now's the time to do that, because you need to take your quick little pre-test here. And when you're done with that, click us back. All right. All right, everybody, welcome back. We hope you did your quick little pre-quiz. Now, don't worry if you didn't know the answers, because that is what Olga is about to teach us. I didn't know the answers either. So Olga's going to teach us all about this. And at the end, you're going to have to take the exact same test over again and see if you learned anything. So listen very carefully, and we are going to get started. So you said this big giant word, chemoluminescence. You know, what exactly is that? Is that something we actually ever really see, or is that just one of those big things that only scientists know about?
Well, scientists do know a lot about it, but every now and then, yes, we might be able to see it, and just we don't realize it. So I'm sure that, on the 4th of July, we've played with glow sticks before. We've seen fireflies in the summertime. Sometimes it's fun to try to catch them in your hands and see them light up and then fly away. Many of us have, if not in the ocean, but at maybe an aquarium or even on TV, have seen jellyfish that lit up. So what they all have in common is they have chemoluminescence, and that's what helps them light up. Especially with jellyfish and fireflies, they use bioluminescence. So that's pretty much the same thing, just in that living organism. So if you think of fish deep, deep in the sea where it's really dark, that sometimes make a light, they use bioluminescence as well. So a lot of animals use it.
So you said, you mentioned things like fireflies. I know when I was a kid, we always used to run out and try and catch all the fireflies and things like that. So what is it inside a firefly that is making it light up? I mean, is it fire? It's called a firefly.
No, well, if it would be a firefly, it'd be kind of hot when you touch them. But if you've noticed, you catch a firefly, there's no, it's not warm to a touch.
Yeah, that's true.
So chemoluminescence is a cool light.
You know what? I have a feeling that's why this is called Cool Blue Light cool could mean more
Exactly.
than one thing.
So
It is going to be neat.
Exactly. I
Well,
thought at
yeah.
first maybe, oh, if it's cool, it's just neat, it's awesome, which it is. So it kind of has a double meaning.
Okay.
Yeah.
So there's something in the firefly. So what is it exactly inside that firefly that is causing that?
So there is a light organ that is located, and it has in its cells a chemical called luciferin.
Luciferin?
Luciferin. So it's kind of a big word, starts with an L, and that is the reacting agent that is used for fireflies to light up.
So you said the words reacting agent. So I have a feeling there's some sort of chemical reaction going on
Exactly.
there, right?
So it's
yeah.
a chemical reaction.
So I mean, that luciferin, is that what you said?
Yes.
That's a type of chemical, I assume?
Yes.
Yep. And if there's a chemical reaction, that means that chemical is reacting with another chemical?
It's reacting with another chemical that is making a product.
Yeah, I guess that's probably on this next page here, this little formula you have here. So what's it reacting with, and what's happening? Explain this little yellow formula. You got A plus B.
So you have, so what pretty much means is this is a very standard formula for how light is produced in chemiluminescence in a reaction. So A plus B, those are your reactants, yields to C plus D, which is your product, and the C has the little asterisk, and then that yields to another C plus light. So pretty much those letters there are just to make it easy to understand the simple concept. So what C is an excited state. So that doesn't mean it's just excited. An electron is very happy. It's really, really excited, like, wee, I get to light up. But also that means that it's going from the ground state and it's being elevated chemically. And once it's elevated and the energy state is greater than it was before, then it gives off that extra energy. So it absorbs a photon, and a photon is a particle of light. Photons is what light is made out of. And then while that energy is high, you have light that's being produced as well. So that's when, until it collides with a nearby particle or element or anything along those lines.
Very neat. So that, let's see. So that little C with the little asterisk.
It's a little star.
Yeah, the asterisk is that extra electron you said?
It's that extra
Excited,
electron when it's excited, so it's raised from its ground state.
And you take that off and it produces light.
Yes.
Without heat. Why it's
No
called
heat.
cool.
Yes, so this one for chemoluminescence, it produces a cool light. So same way with your fireflies. When you catch them, and if you ever touch their little bellies. Now you want to be nice to those fireflies. You don't want to squish them or anything. We want to let them go. We want to see them, live a happy life. We want to see them fly in the sky, but it's okay. It's harmless to catch them for a few seconds. You can touch their little bellies, and in the summertime you'll notice that it's a cool feeling, sensation. It's not warm. They're not warm.
Cool. Well, very, very neat. All right, so Olga, now we know fireflies light up. You mentioned jellyfish. Let's talk about, adaptations. Why would an animal even do that in the first place? It seems to me, at least, they kind of, want to hide and not, broadcast, here I am. So why would an animal be doing this chemoluminescence, or when it's in an animal, you said bioluminescence?
Exactly. So bioluminescence is really important to some animals, and they need it for survival. So some animals could use it to lure and catch their prey. Sometimes they could use it for camouflage, depending on what their background is, and other times, just to attract others, like, to find a mate or to find other little friends. If you have seen the movie Finding Nemo before, you have probably seen where Nemo and Dory are swimming in the very, very deep, dark ocean. All of a sudden they see a light, and then it's a big, scary looking fish. That's an anglerfish, and he is just one of many different organisms in the deep sea that uses bioluminescence as well. And also, if you notice jellyfish, they typically have like a neon, like a green or a blue color. That's because the wavelengths of their colors that they're emitting are a lot shorter than, let's say, red. And it's also a lot easier to transmit in water as well. So that's why we typically, in the ocean, we don't see like red fish swimming around. We see more like blue or green.
Oh, okay. Very,
It's a cool
very
fact.
interesting. Yeah, very cool stuff. So the next section in our book here says, how does chemoluminescence help us in the real world? Now, I have a feeling we're going to talk about that, but I just thought of something. We're talking about cool blue light. Fireflies really aren't blue, though, are they?
Yeah, they're kind of green. Yeah, a
So,
little bit. Maybe yellow.
We talk about luciferin being the chemical that causes the fireflies to light up when it does a reaction. Now, are there different types of chemicals that do the same thing?
Yes, so luciferin is a protein that's used as a reacting agent with, in the case of fireflies, with oxygen to produce that light. You know, the electrons in the more excited state to give off more photons. Now, there's other proteins for different animals. So there's equorin, that's a fancy word that jellyfish use as well. Luminol is a chemical that's used as the reacting agent for chemiluminescence. So that helps maybe us humans more in the real world than, I mean, it would be cool if we, you know, like our ears lit up or something, but we don't have bioluminescence because we, you know, adaptation-wise, humans don't need it.
Right.
Would be cool on Halloween though, maybe.
Yeah. So then, you know, we don't use it in that way, but I have a feeling there are a certain group of scientists that actually do use luminol, like you said, for a very important purpose. What kind of scientists are those?
So crime scene investigators, forensic scientists, you know, the guys that do the science to find the bad guys, they use luminol all the time.
All right, so when you're talking about the luciferin, you said it reacts with an oxygen in order to make that kind of greenish yellow light. So what does luminol react with to make its light?
So luminol typically reacts with some kind of metal. In this case, in a crime scene investigation, it reacts with something that's an iron. And iron is a metal. So in this case, if you think of blood, like if a bad guy, there's a murder scene or something happens, and then there's blood stains around, hemoglobin is the protein that's found in blood that is very important for the scientists to get hold of because they use the iron in that blood that reacts with the luminol to make that blue glow so they can catch the bad guys.
Cool. So, I mean, it says we had that one little formula, the A, B, and C formula there. Looks like you gave us another formula, a little more complicated one that shows the actual reaction of luminol. So that is pretty cool. I know we are going to be doing an experiment a little bit later. We're not using blood though, are we? We're going to use a chemical to kind of replace the blood and things like that. What's that called?
So we're not using blood today. Don't worry, there's no blood in the bag. That'd be a little bit eerie. We are going to today use a luminol mixture with a copper sulfate mixture. So that is a metal as well.
So it just reacts with different types of metals instead of
Yes.
iron. This time it's going to be copper. We'll get more details on the experiment in a second there. We need to finish learning first, but we're just about done. I know you got your book in front of you, but we got some really cool pictures of a crime scene investigation. So tell us a little bit about how that's going to help them. So we know it reacts with blood. What would a crime scene investigator do if they came to a murder scene but maybe it's kind of cleaned up, you don't really see blood, right? I mean, they can clean up the mess, can't they?
Exactly. So the bad guy, he'd easily hide his tracks. But, once he had that blood on something, even if you try to clean it up or whatnot, you may not be able to see it at first in the light with your naked eye, but that's when the scientists would come in and use that luminol substance on just anything that, could have been touched or anything that blood could have been on, because in case of blood, the hemoglobin in it, with the iron that was on the surface of whatever was touched, if you put some luminol on it and you turn off the lights, it should be able to glow.
Very cool. So using real world science to solve real world crimes and catch the bad guy. Very, very cool. So we kind of got a basic background now. Now I think we are going to move on to doing a really cool, pun intended,
Cool, yeah.
a real cool experiment with luminol and maybe create our own light. Oh,
Let there be light.
yes, absolutely. So what we're going to do now is we're going to have you get your little container here. You're going to go ahead and open that up, and you're going to get out your little booklet. That is this guy right here. So we will see you in just a second. Go ahead and get that out, get everything set up, and we'll be right back. All right, everybody, welcome back. We got our little booklet out. We're going to set this booklet aside right now, and we're going to start taking out stuff out of here. So what are these three little things here?
Those are our three little chemical mixtures that we have, and we can put it on our nice little wooden block to have them standing.
So we're going to set that up right there. We got our water right next to it there. And then we got some little popsicle sticks, probably for stirring or something, I imagine. A little dropper. And some little plastic containers. Spoon, a teaspoon, and a couple little teeny tiny measuring spoons. So we got everything laid out there. Now the cool thing about this one, you can see this is actually a pretty big little booklet that's included here. It's got several different experiments that you can do. For this video, we're just actually going to do experiment number 1. And then you guys are welcome, if you'd like, to go ahead and read through and do, I know there's all different kinds of variations to the experiment and kind of other things you can test. So it's not just a one-time thing with this, so that's pretty neat. But we are going to go ahead and just do experiment 1. So it says you will need a dark room to see the reaction. We can go ahead and set everything up now and get it started. So it says that we're going to need
1 cup.
one of these, so we'll get that there. Now, again, because there's lots of experiments, we're not necessarily going to use everything. So we got one of those, the others aside. And then for this one, we're not going to need this little one with the lid right yet. That's for a different one. And we need a stir stick, one of our, or 2 of our little measuring spoons here. And then we're not going to need these, so we'll put those aside. So I'm going to go ahead, I haven't done this yet, so I'm going to go ahead and try and do it. If I get stuck, will help me out here. We'll see what we can do. So it says, add 1 small scoop of luminol mixture. So that's, okay, right here. It says luminol mixture, so I guess that's it.
And 1 small scoop of perborate mixture to the cup of water. So should we put the water in the
Oh,
cup
yeah,
first?
we need to do that first. Here we go. So open up your little cup of water, add it to your big cup. All right, we'll set that aside. All right, now I got my luminol mixture open, so I'm going to get 1 small
That's
scoop
a
of
small
that.
scoop, isn't it?
Yeah.
It doesn't take much.
And then I'm going to just set that right there for now. And then it says, in 1 small scoop of perborate mixture.
So perborate, that's like a bleach almost. It's like an inexpensive oxygen powder bleach that sometimes could be used with washing, and that helps the luminol create an oxidation reaction that helps the luminol bring the electrons to an excited state. So when those electrons release back, that's when the cool blue lighting should happen. That's really it.
Oops.
Should we explain?
So I'm gonna got my 2. I'm gonna pour those in there. Okay, and then it says
Use the wooden stick to take out a few small crystals of copper sulfate and add it to the cup.
okay. Should I stir it or
I wouldn't
Say this
stir it quite yet.
okay? So here's the one that says copper sulfate.
So you just use the end of the popsicle stick just to.
Oh yeah, those other ones were kind of like powder. This is kind of bigger crystals. So we're gonna scoop out a few of those crystals just like that. All right.
And then now it says, and add it to the cup.
All right. So here we go.
Take the cup to a dark room and observe.
And does it say something about swirl in it? Yeah, swirl the cup gently to help mix. Ooh,
Should we go
You
to
know
a dark
what?
room?
I see something happening.
Yeah, it's turning
Look
like
at
yellow
that.
green. Not
That
very a
is
pleasant green.
really
color.
cool. We'll do it again in dark. Okay, that's exciting. Right, it's just- Okay, Olga, so that is really, really neat. So, what's the chemical reaction that's happening right now here?
That is chemiluminescence.
All right, and so luminol is reacting with,
The perborate and the copper sulfate to make our electrons rise at a higher state, so it will make that light.
all right, that is really, really cool. In the light here, it's kind of a weird looking mixture, isn't it?
Yeah, it looks kind of like a...
That was neat. I have not done that before. You created light. Very, very cool. Now you can see that's just the first experiment here. You got all kinds of cool stuff you can read, and we got a lot of leftover chemicals here, so you can do lots of cool stuff. Remember, all this should be done with adult supervision. So before you move on to trying any other experiments, we just got one little favor to ask you. You know what time it is?
It's time for our post-test.
It's time for our quick little post-test. So, the very last white page here, we want you to go ahead and try to answer those questions. See if you learned anything from Olga. I know I learned some stuff. Hopefully you guys did too. One thing that we do ask is after you take this test, if you can get your parents to take a picture of that pre and post tests and either email it to us at info@hosctn.org, or you can even direct message us on Facebook. That would be great. We would actually love that because we put that and record it and use it for applying for grants and things like that. And there is one other thing that we mentioned earlier, the take-home science Show Us Sunday. We're actually, right after we release this kit, we're going to be doing a post on Facebook that if your parents can take a video of, or a picture, however you want to do it, of you doing this cool experiment. Now I know I had a pretty strong reaction when I saw this. It was like, whoa, that is amazing. Yeah. So we're just going to have a little fun with this one this time. We want to see your most amazed reaction to this cool experiment. So we're going to get your parents to take a video or a picture of your amazing reaction and post it in the comment section of that Facebook post, the HOSC Take Home Science Show Us Sunday, and you will get a chance to win a prize. Whoever's comment gets the most likes or loves, what's going to happen, Olga?
They're going to win a prize from us here at the Hands-On Science Center.
Yeah, so
Special
definitely share those posts, get it out, and let everybody see this amazing project you did. You know, it's a great opportunity for you to win a prize, but it also lets the rest of the people know that we have these cool things going on, because we want to get the word out and show everybody. So really, if you can share that post, it helps us tremendously. What else do we have going on besides these take-home science kits?
We have our Facebook Live virtual classrooms that we have about every Tuesday.
It does have a little advertisement here in your book. This is going to be a really, really fun interactive program. So definitely share that post. Plus we have lots of other really cool stuff going on. What else do we have going on, Olga?
Well, we have our Facebook Science Dailies. So that is a different science theme that we go over every single week, and that includes Try It at Home Tuesday, so fun little projects that you could do at home with materials that you probably already have at your house, answering why questions, why certain things happened the way they do in the science world. Throwback Thursdays, usually about a scientific discovery of some sort or something that happened way long ago and how it impacts us greatly today, and just fun facts, just to keep all the kids on their toes with their interest in science while they're home.
Yeah, some great stuff. And again, with all those, the biggest way to help us is share those posts, gets the word out about these awesome programs, because all this stuff we're doing is 100% free. So we really want to get the word out, but we need your help. We can't keep doing these for free forever. Best way is sharing. If you are able to help financially, if you go to www.hosc.org, click that donate button. That definitely helps us out as well. And I'm going to try some of these other experiments, I think, because there is some really cool stuff. Thank you guys so much for joining us. Actually, I think I'm going to turn off the lights again and take a look at this,
Yeah,
see if
let's
it's
see how
still
it
glowing. Right. Thank you guys. You guys have a great day.